Yeah, welcome to VLSI Simplified YouTube channel. Uh, Today I want to explain about two operators, that is a logical operator and bitwise operator in Verilog. In the last session I explained with the programming part. So today I want to explain this programming part in the Xilinx Vivado software. So I want to explain this one simple program. After that we'll run in the simulation part. Okay. One second. Yes. So this program, if you see, this is a logical operator, a module logical AND operator. So we are initializing reg A comma B comma C for 3 bits and reg X comma Y comma Z initial begin and block and A equal to 5. So you know that if you are giving a decimal value, it will take as a binary value 101. This is a 3 bit, and B equal to triple one and C equal to don't care conditions. So logical AND operator will be defined in terms of two ampersand and okay, two ampersand symbols, X equal to A and B, A logical and B, and Y equal to A and C, and Z equal to B and 0. So I want to display the values. So for this, I need to use a dollar display. The value of X is percentage B, Y is percentage B, and Z is percentage B, comma X, comma Y, comma Z. Okay. So this is the program I already explained in the previous session. And whatever the program you want to do the simulation part, you need to make it as a top module. Here already and is there in the top module. See here, this symbol represents this is nothing but top module. So I want to run the simulation, so that simulation part will be available in the TCL console. So I'm running this simulation part. So run the behavioral simulation. We'll see the values in the TCL console. Okay. Yes, it is simulated. So see this in the TCL console. What are the values of this X and Y and Z? So in the logical AND operation, if it is a 3-bit or 4-bit, if all the bits are 0, means it will take as a 1 bit as a 0. So that means 1 bit, that is 0. The value is more than like 0, more than it is 1 or any the non-zero value, it will take as 1 bit as 1. So based on that, it will do the logical operation. So here you got the output. The value of X is what 1 and Y is X, and Z is 0. Okay. So this result you can see in the previous session how I did the same program I explained in the logical and bit level operator. Okay. So I can close the simulator. So this is logical operation. So closing the simulation. Okay. So next, I want to execute this logical OR operation. Okay. So for execution, this logical OR operator. So in the simulation source, you need to make this as top module. Okay. So logical OR operation, you need to make this as top module. So it is available in the top module. After that, you need to run the behavioral simulation. Okay. And whatever the output you are getting, that you need to see in the TCL console, or in terms of waveforms also you can analyze the outputs. Okay. So it is you are getting the output in the TCL console. The TCL console, if you see, so see here, the value of X is 1 and the value of Y is 1 and value of Z is 1. As you know that logical operator, if any of the input is 1, the output is 1. So either it may be don't care, the don't care value is what, 0 or 1. Okay. So that means 1 or don't care with 1 is means you are getting 1 itself. Okay. So this is the output for logical OR operation. Okay. Logical OR operation. And I'm closing the simulation part. So next is logical NOT. So I am making this as top module. Yeah. Yeah. Okay. Logical not. It's made as top module. So logical not means what? Logical not. If you see the programming, this is logical not. Okay. So that is not operation of this logical not of A, not of B, not of C. Okay. So this is not of A, not of B, and not of C. Run the behavioral simulation. Okay. So if you see the outputs in the TCL console, so see here. So the value of x is 0 and y is x is 101. No? So x is 101 means it will take as 1. The logical not of 1 is 0. Okay. And y is triple 1. It will take as logical 1. And that logical not of 1 is 0. Okay. And z is nothing but don't care. No? So don't care means the don't care values are either 0 or 1. So that means the logical not of don't care is you are getting don't care itself. Okay. So this is the output of logical not operation. Okay. So I'm closing the simulation part. So this is about the logical and logical or and logical not operation. Okay. So next I will come with the bit level and operation. So bit level and means if you see the program, bit level and operation. So what is the difference between this logical and bit level and means logical and whatever the number is there, if it is like all zeros means it will take as one bit zero, and if it is a non-zero value, it will take as one bit. That is a bit number logic one. Okay, here it will do the bitwise AND operation. Okay, so that means each and every bit it will do the AND operation. So that we discussed in the last session. So this is the difference in the logical AND operation. There are two ampersand symbols. There are only one ampersand symbol. Okay, that is the difference between logical AND operation and bitwise bitwise AND operation. Okay, so same program, just one change we need to make. We need to remove this ampersand. Okay, so this I am going to execute. Okay, so for execution, bit level operation, the simulation sources, bit level and operation I need to make as top module. Okay, I need to make as top module. So here I am making as top module, and go to run simulation, run behavioral simulation. Second, it's not responding. Once we'll wait.